I hope you all are doing great. And now we will be discussing about exploring the world of video understanding, particularly as in multimodal AI. About myself, so I am a researcher around deep learning and multimodal and applied generative AI. Specifically, I have previously worked for Shaga and currently working as a developer advocate, kind of backend and AI engineer at 12 Labs. So let's first understand like what is video understanding. So how many of you know about this domain? You can just raise your hand like if you know about what is video understanding domain. Okay.
The understanding of what, sorry?
Video understanding domain. Okay, I can't see any hands, so we can talk it briefly. It's kind of a new domain or a branch in an applied generative AI, which is kind of in a very early stage, I can say. So, and like after 6 months, it will be a major domain specifically. And if you will just search around any apps, like let's say you can just search around Gemini Cookbook, video understanding, or OpenAI Cookbook, you can find all the resources around it, and they are also working around it. So we'll be specifically talking about all the models, comparability, and about the whole domain, and specifically what is becoming like after 6 months eventually for our builders and also for the content creators. So why we are talking about videos? Because as per like the IDC white paper, 90% of the data is in videos. And the special things about video is we have visuals which are like, let's say we can talk about a discrete frames, but having a temporal dependence between them. Even at the same time, the audio is also there. So we are talking about multimodalities at the same time, right? So the problems which are there at the current moment and because of which we need a video understanding domain is the videos that we have, we need to supervise it to make it labeled or to add a tag or to do a description. Let's say for an example, there is a podcaster who just recorded a 1 hour of a podcast video. Now he want to release short clips or reels videos or wanted to have a highlights or a timestamp. It takes more than an hour because that person needs to analyze the whole video, write down, okay, which time step I have talked, which topic, which was the segment of that. So that takes around more than a 2-hour process of doing that, which is very intensive. Even if I talk about the scenarios like video stock footages or like that, where you have lot of unlabeled videos and you need to tag or label them so that you can use it in an efficient manner. So that's a very big problem. Second thing is you can't search around videos. Search around, I mean, let's say you have an album of videos and you wanted a very specific moment or very specific thing or clip you want to find on, but you can't find. You can just have like a facial recognition is the only feature which you can look for, because for that you need a semantic understanding. So that is also one of the problem. The third problem comes here is all the LLMs used to treat videos as a frames, and the videos are being shot as a 30 frame per second, and mostly these LLMs used to take 1 frame per second. Because of that, lot of the temporal dependence or the connectivity between the frames get lost, and also the audio which has been attached with the video is not been taken into consideration, which could play a major role if you are a content creator, if you wanted to find a very specific moment which have a audio. Okay, let's say you have a whole, you are in a sports entertainment industry and you have a whole clip of a gameplay of 4 or 5 hours, and you want only the specific moments where the crowd cheers louder, and you need that clip only. At that time you can't find it because the audio is not taken into consideration, only the frames were taken into consideration. So that are all the problems with the video understanding, and we will be talking about how this all can be solved by just having a video embeddings. And also we will be talking about other models with Pegasus, which is used for video to text, which is used for the analysis of the video, or you wanted to create a text around it after analyzing the video. So if we talk about Marengo 2.7, so it's a multimodal embedding model which can take image, video, audio, or even text and creates an embedding for you. With that embedding, what all you can do is you can just detect a motion, and as per that it can retrieve that for you particularly, or you can just do a object search or logo search, so that if there is any specific object you need to find from multiple videos, you will get that specific moment with the specific timestamp of start time and the end time. Even if you wanted to have like a soothing music or voice which is going on in the video and specific clip around that, you can do that. So that is what eventually comes towards multimodal embedding, and also towards any-to-any search. So what is multimodal embedding? As we told about, like as we discussed, like all the modalities, whether image, video, audio, or text, and we are just using an encoder structure to just get an embedding and for the searchability and efficiency. And that all takes us to any search, where you are providing any type of a modalities. And let's say I just search with an image. Okay, let's say this is a horse and I need to find all the videos which contains that. So I'm giving an input as an image and getting an as a video. Or let's say I'm just providing a text and I'm getting an audio around it. So there are a lot of stuff which can be done. If we just go more deeper into the architecture, so how does it work? When the video has been provided, the video has been broken down into two parts. First is the visual and the audio. And as per the specific encoders for the visual and the audio, it has been handled and the vector representation has been created here. And the gated fusion module has been used to merge that audio and video's vector representation, so that we get a multi-vector representation. So let's see the use case and understand more. Okay, what's the power of this embeddings? So let's say I have this logo and I just wrote like identify the Chase Bank logo in a complex viewing angle, and here I got the top 3 result. Can you find the logo? Maybe in next. Here you can see, like you can even see where are the logos, and it provides with the start and the end time itself of the clip, so that you can find it at a very specific moment. Or let's say, so that was the object search or the logo search part. Or the next thing you can do is text to video, is like you can just have a query of multiple New England Patriots pressure and blocks, so something as a scenario based, and here you got the whole result. But in result you can notice like there is a timestamp which starts from 5 seconds, some 16 seconds or 5 seconds. So it finds the specific moment where that action is happening. So this is what the embeddings can help you with in a very generic format. But the embeddings, when like embeddings are more richer, you can have more efficiency around other use cases around motion understanding and OCR. If I go on more, like this is one of the application which has been built around using the same embedding model for the recommendation, because recommendation are based on others activities, right? Not on visuals. So here the visuals are taken into consideration for the recommendation, so that if here the fantasy is selected, so you get that type of reels. And if I just showcase the architecture of how does it work, so let's say I have the list of content or the video resources, and I just provided to the Marengo Retrieval 2.7, and here I did all the embedding generation, and now I have stored all my videos into a vector database, so that now whenever I provide a preference or a search in an optional manner or a very much tag-like manner, that text is converted into an embedding, and then it's searched from the database, and it provides me the result, and I can change the pressure and like the preference, and it just goes on into the loop. So if we just see the metrics around how does it improve as compared to other open source embedding or multimodal embedding models. It specifically improves a lot in motion search because of temporal dependence preservation, and general image search and logo search is the main part here. Now next, let's discuss about Pegasus. So we discussed about generating and embedding. Now we'll see video to text generation. For that, whenever we provide a video, there is a video encoder which converts to a video tokenizer. Video tokenization, the tokenizer is an anchor which actually relates it with the text embeddings. As Pegasus has been trained on like 1 lakh of videos with respect to the description of that also, and after that it interacts with the language model. So whenever the user prompt is provided, it converts to text token, and then it interacts with the language model. So what's the best part of this is, it not only provides you the description, but also where that action is performing, like what's the timestamp around it. And if I just showcase the use case around it, so let's say this is an ad of Amazon and Amazon Go, if you know about that, and I just provided a prompt as suggest edits for the ads to make it appeal to kids, and break down by timestamp and include voiceover as appropriate. So this is kind of a stuff you are asking so that you can have like a content localization. You wanted it to be drafted for kids, and also to help the content creator on how to edit stuff. And in the response, you can see it suggested the response in a timestamp manner, and also providing the assets which are being mentioned as per kids. So it just says as playful animation of food items to capture kids' attention. So it captures the whole view and also analyzes the video at the same time. If I show the next use case, which is around sports analytics, and here I provide a NBA video of sports and provide it to create the summary, and also at what time the game ended, and what is the final score. So here you can see it provide me the summary, and the game ended at time this, not the end of the video, but eventually when in the video clip it ended, and what's the final score. So this type of application is being used in various sports related organization to generate real videos, to create content around it, specific clips for that, and also eventually for the caption generation or the real-time transcript generation. Next is the best use case which you can go for, or maybe use it in your application, which is metadata generation. Because the major problem comes is you have videos, you have a lot of videos, maybe event videos, or maybe if you are working around an organization which deals with stock videos, at that time labeling the data is a very crucial part. And you can see the power with the prompt itself. It just says build an enterprise ontology and knowledge graph of all the actors having a connection with other actors, and how does it work. And it provided me a JSON of all the entity, and this JSON I can just provide it to the graph and just visualize, okay, which connection and what are the relations of that. So there is one more application which has been built, which I can show is there are like thousands of videos of video footages of nature, of animals, and at that moment, like all are like unlabeled, and you need to have like what type of shot is it? Is it close-up shot? What type of animal or type of scenery is that? And also to detect that animal or the location. So that all stuff can be auto-generated with the model, so that it saves a lot of time. And that is how it works. So we saw like about how the Marengo works, how it generates the embedding, how it helps for the search or the embed, or the Pegasus one for the generate one. Next, if we see about open source video to text arena. You might have heard about a lot of chatbot arenas and where we used to experiment with lot of LLMs to see how it performs for a specific prompt so that we can choose. And as per that, if you know about LLM SYS is chat arena is one of the trustable sources in Hugging Face, where you can just check around various LLM and you get a score on the base of user voting around it. But there is no text arena, like video to text arena kind of a format. So I thought, okay, let's build that. So I built like I am the maintainer of this repository where you can just switch to any models. You can just provide your video, or there are other sample videos at the same time, and you can just provide a prompt and compare the comparison of how well different models works around videos. And particularly here you can see the comparison of one of the dance video which I have selected and the model here as Gemini 2.5 Pro experimental model and the Pegasus model here, and you can see how different the response is. And there are other models you can experiment with that. So, and this is the QR for the repository, so you can just have an explore to that repository, and if you wanted to contribute towards it, you can contribute, because I'm updating a lot to this repository to include other models at this moment, and I guess I will make it more publicly for contributors by next month. Okay, so next is these are the models which are present at this moment: Pegasus 1.2, Gemini 2.5 Pro. I guess yesterday only Gemini 2.5 Pro and Flash came, so that all model you can maybe contribute to, or I will surely be adding that. So now we understood about what is video understanding, what are the problems, how it can be solved, what are the various use cases. Now we will be talking about the current stuff on which all the organizations are working on at the same moment, which is AI agent with video understanding. How many of you know about vibe coding, and how many of you do vibe coding? Okay, I can see hands. Do you know about what is vibe editing? Any idea about what is vibe editing? So vibe editing is not a word at this moment, but it will be in maybe in 6 months, where you can just have, like, let's say for this event only, you have like the videos, and you can just connect it with your AI, and you don't need to do any stuff. You just need to prompt and your video will be edited by itself. So let's see like what is the progress going on in the research. So we will be talking about the research stuff at the same time. So let's discuss about what are like very basic to tools to agents. So as we know, there are various agentic stuff, right? LangGraph, OpenAI, agentic framework, or Llama Index, or Crew AI. But specifically, if we talk about tools, we need to discuss about 4 points on which it works around agents. First is understand, plan, act, and reflect. So here in this you can see user provides the query, and make a plan is one of the function here, where the task decomposition happens and you get appropriate what are the specific tasks which needs to be catered on. After making a plan, the execute task comes into the picture, where it identifies the exact plan, exact task, and as per that it chooses the appropriate tools for that. And at the same time, at the last, it asks all tasks are completed or not, and it iterates itself, and with the help of chain of thoughts method, it iterates itself and reflect until we get a fruitful result. So this is the pattern which has been used, which is like task decomposition or recursive reasoning, and human in the loop or maybe automative stuff works here. And what makes like video agents different is videos, as I told, videos are not like one modalities. We are talking about frames, temporal dependence, spatial understanding, and even audio at the same time. And if we talk about video, we are talking also about at that instance what is happening at a clip level, what is happening at a what we say scene level, what is happening at a narrative flow. So there are like many hierarchy also comes into the picture. And with that research, like these are some of the research which is happening at the same moment. First is like we can see of Ohm agent, where it works around drag, divide and conquer method, which works around it just breaks down the video into 3 parts versus scene detection, facial recognition, and audio to text generation. And after that it just uses like multimodal LLMs to draft that scene, and after that it captures the scene into an embedding format. So whenever you provide a query, you get an extract stuff, but it is very hectic to do this whole towards the loop format. Then the second comes here is an agentic flow, which tells about you don't need to understand, like your model don't need to understand the whole video. You need to extract only the relevant stuff you need at that moment, and iteratively your agent should learn on how it's working. And agent don't learn, right? Like agent just do the decision making stuff. So it just iteratively stores the retrieve frames in a database, like that stuff. And here you can see like it just basically use clip. Clip is a multimodal embedding of Hugging Face, which actually embeds the image into embeddings, and the LLM is integrated to it. And here the third part you can see is the Lave system, and Lave system just provides us the information of building an agentic video understanding architecture in a modular way. Modular way as in a 3 steps. First is like the task decomposition. Second is to have the specific tools for that specific task, and then third is having like these subtle like titles for each video or whatever the task you need to have, and you can just change or have an orchestration around it, and you can just use it for various other purposes. So these are all like the research around the same, and that's how like the Jockey came into the picture. Jockey is an like open source conversational video agent where you can just query and do like video tooling and editing stuff, and it works around like planner, worker, reflector architecture. It's the very same rule which I told about. Is user provides the input to the supervisor, supervisor tracks on what all is happening, it then sends to the planner to decompose the task into appropriate steps. After that it sends to the instructor to choose the appropriate tools, and specifically if we are talking about search in a text input, at that time it will choose Marengo. If we are talking about something around generation of text or anything of a generation, it will choose for the Pegasus. Or if we are talking about just getting a video and merging it or editing it, at that time the open source FFmpeg works for that. So here the reflect is the component which tracks on the whole context of what is happening, and it also defines the further steps which is needed to be taken on. Specifically here, the tools you can see like the Marengo and Pegasus are being used for specific search or the video to text generation, but for the whole agentic workflow, you can use any LLM orchestrations models like OpenAI or Gemini. You can choose anything. And as per, if we talk about agent transparency, so it works around whatever the action which is happening at the same time, maybe retrieving the videos, taking an action, everything is like being provided as a transparent on the user platform, so that user gets to know what is going on underneath and which type of model is being used for that specification. And here is the use case. I guess it won't be that visible, but there is a query as search for inspiring stories of people who have overcome obstacle to achieve success in their fields in TED Talks. And the agent is thinking and providing, okay, searching with this model, found out this videos, and then I provided, okay, summarize these videos in 3 sentences or less. So it provides me the whole videos with the summarization, and these are like my whole library of videos which are there. And if I talk about like other stuff is like find 5. So there, sorry, in previous one, in the first step, when I told search or maybe find, any type of this triggers will eventually take a tool of Marengo to search for that. Whenever I am talking about summarize, analyze, generate, at that time, the video to text model will be triggered by that. So that all stuff will be taken care by the planner, by the supervisor. And here also you can see, find 5 TED Talks on AI and robotics. So it says, okay, searching for it, initiating search for searching with this model, computed top result, and you get this 5 videos around AI and robotics in TED Talks. And here in the similar manner for the Pegasus one, it generates the analysis for the videos. So, and the major problems is about at this moment in content creation, specifically areas, is highlight generation. And the problematic thing is the time, the duration you have for the content creation, like the content, like 1 hour, it takes double or 2.5x of that. But if you automate it with like AI, it saves a lot of time. So here, like MLSE, if you know about that, it's like sports and entertainment industry in Canada, and they converted their task of 16 hours into 9 minutes. So that's how like the AI agentic is that much powerful. And here we are at the last stage of what is the future ahead with Jockey, with AI agentic, or with vibe editing for that instance. So next is like flow aware trajectories. Flow aware is just to help around editors to automatically the AI will understand, okay, which type of clips ahead that creator or user will be needing, so that AI will craft that eventually in that process, or maybe will just have like the best moments or the highlights already been calculated by itself, so that it makes the process of doing the editing for the user more ease. Next is like contextual meta learning. So contextual meta learning is kind of a very been researched in all type of AI agentic workflows at this moment. AI agentic workflow moments, in which specifically the agent learns from the user behavior, user patterns, and it does action like that. So here in this case, if I just talk about videos, it analyzes, okay, what's the pattern, what's the behavior, what's the preferences of the user specifically whenever it tries to edit, and eventually it will apply by itself by learning the, like as I told, like meta learning about the context of how the user uses the platform on a project level or maybe on an organization level. And at the last, it's like multimodal intelligence at scale is like there are a lot of stuff which needed to be integrated in tooling perspective. Now you can just edit your video or merge that or just trim it like that, but there are more capabilities which can be added if you know about SAM2, which is by Meta, which is for the segmentation of the videos, or background removal, or content generation field, maybe video generation or the audio generation, and integrating all that tools to the platform is what it is. So you can search for Jockey GitHub and you can find the repository. You can also contribute towards it specific to the tools or the integrations. And that's all. That was all about the talk. If you have any ideas about videos or anything about multimodality or anything about AI, you can reach out to me via LinkedIn. Yeah, thank you.